Objective: distinguish between soluble and insoluble salts. Use solubility guidelines for aqueous solutions to determine solubility of salts. How can we distinguish between soluble and insoluble salts? Ionic compounds that dissolve in water are soluble. Salts that are soluble in water typically contain at least one cation or anion that dissolves in water, while insoluble salts are ionic compounds that do not dissolve in water. Salts that are insoluble have strong attractions between its positive and negative ions that are too strong for the polar water molecules to break. What are solubility guidelines? Solubility guidelines can be used to predict if a salt would be expected to dissolve in water. Reference Table F contains the solubility rules for the New York State Regents exam. How can we use solubility guidelines to determine if a salt will dissolve in water? Example 1. Determine if NaNO3, sodium nitrate, is soluble or insoluble in water. First step is to identify the negative ion in the salt. Here it is NO3. Next, we will locate the anion in reference table F and identify if it is soluble or insoluble. Here we recognize that it is soluble. There are no exceptions. Step 3, we identify the cation. This is sodium Na. Next, we check if the cation is an exception. There are no exceptions. Therefore, NaNO3 is soluble in water. Example 2. Determine if PbCl2 lead chloride is soluble or insoluble in water. Step 1 is to identify the negative ion in the salt, PbCl2. Here it is Cl. Step 2, we locate the anion Cl- in reference table F, then determine if it is soluble or insoluble. Here we recognize that it is soluble. Step 3, we identify the cation for PbCl2. Here it is recognized to be Pb. Next, we check if the cation has an exception. Pb is an exception. Therefore, PbCl2 is insoluble in water. Example 3. Determine if SrCrO4 is soluble or insoluble in water. Step 1. Identify the negative ion in the salt. Here it is CrO4. Step 2. Locate the negative ion in reference table F and determine if it is soluble or insoluble. Here we recognize that it is insoluble. Step 3. Identify the positive ion. Here it is Sr. Step 4. Identify if Sr is an exception. Here we identify Sr is not an exception. Therefore, SrCrO4 is insoluble in water. Example 4. Determine if NaCO3 is soluble or insoluble in water. Step 1 is to identify the negative ion in the salt. Here it is CO3. Step 2, locate the negative ion in reference table F and determine if it is soluble or insoluble. Here it is located in an insoluble column. Step 3, identify the positive ion. In this example, it is Na. Next, identify if the positive ion is listed as an exception. Here, when combined with group 1 or ammonium, it is an exception, and Na is located in group 1. Therefore, since it's an exception, NaCO3 is soluble in water.